Welcome to Mathematics on TV. My name is Mr. Kamau, and I'm going to be taking you through quadratic equations. This is Form 3 Mathematics, preparation for Kenya Certificate of Secondary Education. Now, I'm going to pick up from where we stopped in our previous lesson, and we were discussing quadratic equations. And we said that a quadratic equation is of the form ax squared plus bx plus c is equals to 0, where a, b, and c are constants. Earlier on, we had said that if it does not have the equal sign, then it becomes a quadratic expression. But now it is a quadratic equation because it has the equal sign. Then we said we can solve this various ways. We can solve it by factorization. We can solve it by completing the square. We can also solve it using the quadratic formula. Now, in this lesson, I would like to discuss in details about the quadratic formula. If you still can remember, the quadratic formula is given by x is equals to negative b plus or minus the square root of b squared minus 4ac, this divided by twice a. So you can see that this formula will give us the solution to any quadratic equation because it has x on the left-hand side and it has the constants on the right-hand side. Now, generally, in a quadratic equation, we will know the values of a, b, and c. And therefore, when you substitute those values in this formula, you'll be able to obtain the values of x that satisfy the equation. Now, in this lesson, I want us to discuss the nature of the roots. Nature of the roots. Now, what are roots? I had already mentioned this earlier. The roots of a quadratic equation are the solutions. A quadratic equation will normally have two solutions. And so those solutions are sometimes called the roots of the quadratic equations. Now, let us use this example to study the nature of roots that we get when we use a quadratic formula. X squared minus 5x plus 1 is equals to 0. So now, in this quadratic equation, you can see that the coefficient of x squared is equals to 1. So we say a is equals to 1. The coefficient of x is negative 5, and therefore we say b is equals to negative 5. And lastly, c is equals to 1. C is equals to 1. So now we substitute those values in the quadratic formula. So we'll have x is equals to negative b. So negative, I'll put a bracket because there is a negative sign before 5. Negative b. You see, b is negative 5. So we have to say negative, then put a bracket, and then negative 5. So negative of negative 5, then plus or minus the square root of negative b squared, that is b squared, b is negative 5, so b squared minus 4 times a is 1 and c is 1. Close the bracket, divide by 2a, 2 times a. Okay, so A is equals to 1, B is equals to negative 5, C is equals to 1. And so, if we put this in the quadratic formula, we will have a negative of B. B is negative 5, so negative of negative 5 plus or minus the square root of B squared minus 4AC divided by 2A. Now, but the most important part of this quadratic formula is this part. That is the part we are most concerned about in our study of the nature of the roots of a quadratic equation. So let's see how it behaves. So we are interested with B squared minus 4AC, which in this case will be negative 5 squared minus 4 times 1 times 1. This is equals to 25 minus 4, and this is equals to 21. Now that is very, very important. The number 21 is, for one, positive. And so its square root is real. It's possible to get the square root of 21. Why do I say the square root? Because B squared minus 4AC is under the square root, as you can see. So what we are saying is that this part of the solution can be replaced by the square root of 21. So we can say it is plus or minus square root of 21. And the denominator, of course, is 2 times the coefficient of x squared, which is 2 times 1. Now, what does it tell us when the square root, this is the square root of a positive number? It tells us that the roots of the quadratic equation are real. The roots are real. And in this case, if we work this out, you find that the solution here will be x is equals to negative of negative 5 is positive 5 plus or minus the square root of 21 is 4.583 divided by 2. So this means we have two solutions. One of them, if I call it x1, will be equals to 5 plus 4.583 divided by 2 is equals to 9.583 over 2, which is equals to 4.79 to 3 significant figures. And then the other root will be equals to 5 minus 4.583 divided by 2, and that should give you 0.21. So now this is the reason why we say the roots are real. They are real numbers, because 4.79 is a real number, 0.21 is a real number. That condition is fulfilled when we have b squared minus 4ac greater than 0. As in our example, you can see that we got b squared minus 4ac is equals to 21, and 21 is greater than 0. So that is condition number 1, when b squared minus 4ac is greater than 0. The other condition is when b squared minus 4ac b squared minus 4ac is equals to 0. And I'll give you an example for that. Take the quadratic equation x squared minus 6x plus 9 is equals to 0. So supposing you are to solve x squared minus 6x plus 9 is equals to 0. Solve means find the values of x that satisfy that equation. So using the quadratic formula, we will say x is equals to negative b. Negative b means negative of negative 6 plus or minus square root of b squared. That would be negative 6 squared minus 4 times a is 1 and c is 9. This divide by 2 times a, and a is 1. And now, remember, we have said that what we are interested in is this part here. This part. Now, here, if we are to extract that, we will see we have negative 6 squared minus 4 times 1 times 9, which is equals to square root of 36. 36 minus 36, that is 4 times 1 times 9 is equals to 36. And this is equals to square root of 0, which is equals to 0. Now that is our condition number 2 that gives us the nature of the roots. Now when b squared, this means that b squared minus 4ac is equals to 0. And there will be a number of quadratic equations that you come across where b squared minus 4ac is equals to 0, meaning that this part here, this part becomes 0, and therefore we will be left with x is equals to negative of negative 6 plus or minus 0 divided by 2. And this will give us positive 6 over 2, which is equals to 3. Now, this kind of quadratic equation, we normally have 2 equal roots. The roots are real. As you can see, the number 3 is real, but also the roots are equal. So the solutions of this kind of quadratic equation has got equal real roots. So that is when b squared minus 4ac is equals to 0. The third one is when b squared minus 4ac is less than 0. And we have an example for that. Let's solve x squared plus 6x plus 13 is equals to 0. Now, to solve this, applying the quadratic equation, we will have x is equals to negative b, that means negative 6, plus or minus the square root of b squared is 6 squared minus 4 times a is 1 and c is 13 divided by 2 times a, which is 1. So looking at this part here, we have the square root of 6 squared, which is 36, minus 4ac, that is 4 times 13. 4 times 13 should give you 52. And when you do the subtraction, you should get this is equals to square root of negative 16. Square root of negative 16. So we need to find the square root of negative 16, and that is not possible. It's not possible to have a square root of a negative number. And therefore we say that this equation has no solution. It has no solution, or it has no real roots. It has no real roots, so it has no solution. So these are the three type of quadratic equations that we can have. One has got two distinct roots, the other one has two equal roots, and the third one has no real roots. So now you can see that we can discriminate the nature of the roots of a quadratic equation by finding whether b squared minus 4ac is positive, 0, or negative. So in summary, we'll say that if b squared minus 4ac is positive, we have two distinct roots. Two distinct. And we are going to look at examples for that. And then if b squared minus 4ac is equals to 0, or is 0, then we have two equal roots. Two equal roots. And lastly, if b squared minus 4ac is negative, then we have no real roots. So those are the three natures of the roots of a quadratic equation. So having said that, let me give you a question. Now the following question will take us back to what we did in a previous lesson. Supposing you are told to solve the following equation using the square root tables where necessary. So x plus 3 squared is equals to 14. To use the square root tables, it means that we have to get, first of all, the square root on both sides. So taking square root on both sides, take square root on both sides, then we will have square root of x plus 3 whole squared will be x plus 3. It's only the square that will disappear. This will be equals to, now remember what we said, that square root has plus or minus, both plus or minus. So you say plus or minus square root of 14. The square root of 14 from your tables should give you 3.742. 3.742. So we will have two solutions in this kind of a question. What remains here is to take 3 to the other side, and it becomes negative. So this is equals to plus or minus 3.742 minus 3. And so we have one of the solutions is 3.742 minus 3, which is equals to 0.742. And the other one will be negative 3.742 minus 3, which will give you negative 6.742. Now, in our next lesson, we will, I'll give you more examples, more questions relating to this, and also the use of the quadratic formula, plus the product and sum method that we have learned. So, since our time is up, I would like to bring this to an end, and to let you know that we now have an SMS number where if you need any help or to get support or to get tips on various areas in mathematics, all you need to do is go to your mobile and write message MAT. This is Form 3 Mathematics. So you say MAT3 and then you send it to 21126. 21126, and you will be getting those tips every day. So with that, we come to the end of the lesson. Thank you. Welcome to Elimu TV Mathematics. I'm your mathematics teacher for Form 3, Mr. Kamau. And today we are dealing with quadratic equations. We are going to look at various ways and methods of solving quadratic equations. We have gone through the method of completing the square. We have also discussed using factor method to solve quadratic equations. And lastly, we discussed solving quadratic equations using the quadratic formula. We also saw the nature of roots that you can get from solving a quadratic equation by studying the nature of the discriminant. Now the discriminant is that part of the quadratic formula that is written as b squared minus 4ac. Now, we talked about so many things about that, but in our today's topic, we are going to look at how to solve various kinds of questions that have to do with quadratic equations. So let's take one more question. You are given x minus 7 over 2 whole squared is equals to 13. So remember what we said? Here, you take square root on both sides. So when you take the square root on the left-hand side, since it is already squared, now the square sign disappears, and you are left with x minus 7 over 2. And on the right-hand side, you take the square root of 13, which is plus or minus square root of 13. Now remember we said whenever you take a square root of a number, it has both negative and positive. That's why we say plus or minus. So square root of 13. What's the square root of 13? From your tables, you can get it, or from your calculator. So this therefore becomes x minus 7 over 2 is equals to plus or minus square root of 13 is 3.6056. And from there, we can say take negative 7 over 2 to the right-hand side, and on the left-hand side, you are left with x. So x is equals to plus or minus 3.6056 plus 7 over 2 in decimal form can be written as 3.5. So one of the solutions will be 3.6056 plus 3.5, which will give you 7.1056. The second solution is when we apply the negative sign. So we have x2, the second solution will be negative 3.6056 plus 3.5 and that will come to negative 0.1056. So there we have the two solutions. And these are real roots. These are real roots which can be read off from a calculator. The next question is going to use the factors method. Using the factors method to solve a quadratic equation. So by factors method, solve 2x squared minus 7x plus 6 is equals to 0. Now, if you can recall, for this one, we had to say the product. The product is normally given by the coefficient of x squared and the constant. And always you must consider the sign that comes before the constant, the number. So here we have 2 times 6, which gives us positive 12. And then the sum. The sum is given by the coefficient of x. Also, we have to be careful about the sign that comes in front of it, and this is negative 7. So he said, in this method, you look for two factors of 12, which when added will give us negative 7. 2 factors of 12, when added will give us negative 7. And we have 1 and 12, we have 2 and 6, and we have 3 and 7. So we take 3 and 7, and in that case there will be negative 3 and negative 4. When we multiply negative 3 by negative 4, we get positive 12. When we add negative 3 to negative 4, we get negative 7. So then we rewrite our equation with those factors. So the middle term becomes negative 3x minus 4x, then plus 6 is equals to 0. Then we say factorize the pairs. Factorize the pairs. And when you do that, I have to bring it up here. The common factor here is x, of course. So inside the bracket, we will have 2x minus 3. And then the next pair, the common factor will be negative 2. Negative 2. And then inside the bracket, we will have 2x minus 3. This is equals to 0. Now 2x minus 3 is common in both of these terms. Now we had 4 terms, it reduces to 2 terms. Each of these 2 terms have a common factor, that is 2x minus 3. So we factor it out, 2x minus 3, and you have inside the bracket x minus 2 is equals to 0. So that now we can say either 2x minus 3 is equals to 0 or x minus 2 is equals to 0. So from the first one, we will have, taking negative 3 to the right side, you have 2x is equals to 3, which implies that x is equals to 3 over 2. And from the second equation, we'll have x is equals to 2. So the solutions to the quadratic equation given by factor method is x is equals to 2 and x is equals to 3 over 2 or 1.5. So that is the factor method. Factor method. Then you may also be asked to solve. You may also be asked to solve factorizing or otherwise, or by completing the square. Supposing you are given x squared minus 26x plus 48 is equals to 0. And by factor method, if we say by factor method, we will say the product is equals to 48, that is 1 times 48, and the sum is negative 26. So we find two factors of 48, which when added give us negative 26. And that of course is possible because we can say it is negative 2 and negative 24. And that will work by factor method. However, some questions may not be that straightforward. So I want to leave this to you to solve at your own time. Let's take another question. You are given solve 9x into x plus 1 is equals to 4. 9x into x plus 1 is equals to 4. Now what you need to do in this is to open the bracket and rewrite it so that we have 0 on one side of the equation. So opening this bracket, we will have 9x squared plus 9x is equals to 4. And then bringing positive 4 to the left hand side, we get 9x squared plus 9x minus 4 is equals to 0. Now let's see whether we can solve this by factor method. So we say product is 9 times negative 4, which comes to negative 36. And then sum is equals to 9. So we've got to look for factors of negative 36, which when added will give us positive 9. So if we can say 12 and 3, that will work, isn't it? So 12 and negative 3. Again, this one will work, and therefore we can solve this by factor method. We can solve that by factor method. So there are questions that can be solved by factor method, and there are others that may not be solved by factor method. In that case, you use the method of the quadratic formula. As we continue, I would like us now to think of real-life situations. Real-life situations which involve quadratic equations. So, forming and solving forming and solving quadratic equations. Now you find that there are certain situations which, when you are given, you may be given a narrative and you want to solve that situation. To solve that situation, it may necessitate you to form a quadratic equation and then solve it. Here is an example. You are given that the length in centimeter of a right-angled triangle are x minus 3 and x minus 5. Use Pythagoras theorem to write down an equation in x. Solve the equation to find the lengths of the sides of the triangle. So the length are x minus 3, and x minus 5. So let's sketch a right-angled triangle. Of course, we know the hypotenuse is normally longer than all the others. Then this could be the x minus 3, and this could be the x minus 5 is the shortest. Now, we know Pythagoras theorem is hypotenuse squared is equals to opposite squared plus adjacent squared. Therefore, we write that using the x, we will say x squared is equals to x minus 3 squared plus x minus 5 whole squared. Next is to open the bracket in order to solve. So we open this bracket the normal way, and we get x squared minus 2 times x times negative 3 is 6x plus 9. Then we open this other one, we get x squared minus 2 times x times negative 5 is minus 10x, then plus negative 5 squared is 25. So adding the like terms, this becomes 2x squared. Then we have negative 6x minus 10x is equals to negative 16x. Then 9 and 25, that gives you 34. So this is equals to x squared. We can take the x squared to the right side of the equation, and it becomes negative. So we will have 0 is equals to 2x squared minus 16x plus 34 minus x squared. And so because we subtract x squared, we are therefore left with 0 is equals to x squared minus 16x plus 34. And that is the equation that we now need to solve. So our equation is x squared minus 16x plus 34 is equals to 0. So we can use the method of product and sum. If we say the product is coefficient of x squared times the constant, that is 1 times 34, which will be 34. And the sum will give us negative 16. So two factors of 34, which when added will make 16, are, what are they? We have 34 is 1 times 34, then 2 times 17, and that is all we have. None of them, actually none of them will add up to 16 or negative 16. So that being the case, then we abandon the factor method and probably we use the quadratic formula. So using quadratic formula, we say x is equals to negative of b, this is negative 16, plus or minus the square root of negative 16 squared minus 4 times a is 1 times c is 34, divided by 2 times 1. And the discriminant will be negative 16 squared, that is 256. 256 minus 4 times 34, that should give you 120. So this is equals to negative 16 is positive 16 plus or minus square root of 120 divided by 2, and the square root of 120 is 10.95. So this will be 16 plus or minus 10.95 divided by 2. And therefore, the solution, one of the solutions, x1, will be equals to 16 plus 10.95, that is 26.95 divided by 2. That gives you 13.475. The second one will be subtract. So 16 minus 10.95, then divide that by 2, and that gives you positive 2.525. So you can see that it's possible to solve real life situations using the quadratic formula. So with that, we are out of time. We come to the end of today's lesson. I hope you have enjoyed watching this. Again, to get tips, further tips in mathematics, you need to write an SMS to MAT3, that is for mathematics, form 3, and then send that to 21126. Send it to 21126. Thank you, and God bless you.